Hello, friends. Happy Monday. I hope you had a wonderful weekend. Today in CKLA, we are reading the story called Stars. Our learning targets for today are to explain why the sun appears to be moving across the sky, describe the appearance of stars, demonstrate an understanding of the words dusk and dawn, and compare and contrast factual and fictional texts about stars in a journal. Our key vocabulary for today are debris, dusk, meteor, telescopes, and universe. Debris is a noun, and debris are the pieces left over when something is broken or destroyed. So in this picture, you can see all of the debris, right? Looks like maybe doors, maybe it was a house once upon a time. Okay. Another example would be when I dropped my plate of food, I had to clean up the mess while my dad swept up the debris from the broken plate. Dusk is a noun, and dusk is the time of day just after sunset when the sky is not yet fully dark. In the summertime, my mom lets me play outside until dusk. Meteor is a noun, and meteor is the bright light you see when something flies from space into Earth's atmosphere, like a shooting star. Some people make a wish on the first star they see at night, but I will make a wish on the first meteor I see. Telescopes. We've talked about telescopes before. Telescopes are instruments that make distant objects appear closer when you look through them. Now, when I say instruments, I don't mean like a piano or a guitar or anything like that. Not an instrument that you would play to make music, but an instrument like a tool, okay? Telescopes are fun to use because you can see things in the sky that you cannot see at all without them. Universe is a noun, and the universe is everything that exists, including planets, stars, and space itself. The universe is so big that I can't even imagine it. All right, so what have we already learned? What causes day and night? What causes day and night? Earth's rotation, and a rotation, remember, now put the world upside down on accident. A rotation is when the world spins around like this, spins on its axis, right? Whee! If you were in my classroom on Friday, you got to rotate in our classroom until we were really dizzy. All right. And what is the other way that the Earth moves? So we know that the Earth rotates or spins, and that gives us day and night, right? And what was the other way? It revolves around the sun, or it orbits the sun, okay? And that means that it is going around. So if I'm the sun, the Earth is orbiting, going around me. And at the same time that it's doing this, it's also spinning. I don't know that I can do that on my own. I tried. All right, so it's spinning in two ways. It's spinning like this. It's moving in two ways. It's spinning like this, and it's orbiting like this, okay? If you want to try, you can find something like a hula hoop and put it on the floor, and then you are going to orbit it, which means you are walking around it. And then I want you to go away from the sun, your sun. You are going to rotate, which means you are going to spin. And then once you think you're ready, you are going to very carefully rotate, so spin, and orbit, walk around the sun at the same time. It's pretty tricky. All right. Who can, sorry, the cat's in my way. Kitty, move. So Earth is a planet because it orbits the sun. So on Friday, the last time we had our story, we learned that planets are objects that orbit a star, right? So the only reason that Earth is considered a planet is because it's an object that orbits a star, more specifically the sun, because remember, the sun is a star. Okay, so let me ask you this question really quick. Is the sun a planet or a star? It's a star, right? And the Earth, is it a planet or a star? It's a planet. Very good. No stumping you. All right, so we have already learned about Earth's most important star. What is it called? The sun. And what do you remember about the sun? It's made out of hot gas. And who can tell me how much bigger the sun is than the Earth? It's 1,000,000 times bigger than the Earth. So if this is my size of my Earth, I would have to have 1,000,000 of these to make up the size of the sun. Okay? So it'd have to be really, really big. I don't know that a million of these would fit in my house. What's a gas? What's a gas? A gas, it's not a liquid and it's not a solid. So if you have a diffuser in your home, or if someone's ever cooked in your home and you see the steam coming up from the pots and the pans, those are gases. Even air that you can't really see, but even air is gas. So stars are balls of gas that, stars are balls of gases, even though they appear to be in points as we view them so far away from. Oh my goodness, I did not read that correctly. Let me try again. Stars are balls of gases, even though they appear to be in points as we view them from so far away. So even though they look like they're just little dots, they're actually balls of gas, okay? The sun is one of the billions of stars in space. It looks bigger than the stars we see in the night sky because it is much closer to Earth than the rest of the stars, even though it is still very far away. Because who remembers how long it would take the fastest spaceship to get to the sun? How many months? 3 whole months to get to the sun in the world's fastest rocket ship. Crazy. All right, let's see what else we have. Well, looks like it's time for our story. Remember our key vocabulary: debris, dusk, meteor, telescopes, and universe. All right, so I want you to listen carefully to learn more about stars, okay? We are going to learn about shooting stars, which aren't actually stars at all, fun fact. So I want you to listen carefully to find out what shooting stars really are. When nighttime comes, you can say good night to the sun, our daytime star, and you can say hello to all the millions of other stars that shine in outer space. Remember that stars are hot balls of gas that give off light and heat. Remember, the stars are always out there. Outer space does not disappear during the day and then reappear at night. You can see the stars at night because the sun's light is no longer shining on your part of the earth, but the stars are always there. So if you look out at the sky during daytime, those stars are still there. They didn't leave. It's just that we can't see them because it's not dark enough to see them. Another way to think about this is if you are in the city at nighttime and you look up into the sky, you can't see the stars. Like where I'm from, if I were to look up at the star or to look up at the sky at night, I still wouldn't be able to see the stars because it's too light because of the lights that are in the city. But when I came out here, there are a lot less lights. So I can see the stars much better because it's darker, okay? But they're always there. At dusk, just after the sun has set in the west, but before all of its light has faded, the first stars of night appear. So in this picture, it's dusk, okay? So the sun has gone down, but not all of the light has gone away. So you can still see some light from the sun, but yet you can also see some stars. 1, 2, 3, and then more and more. The darker it is, the more stars you can see. If you live in the city, then you can't see as many stars as people who live in the country can see. Lights in the cities brighten the night sky and make it difficult to see stars. Out in the country, and especially out in the wilderness, far away from buildings, streetlights, and cars, the night sky seems to explode with glittery, twinkling stars. Whew. That's kind of what I had said, isn't it? Bam, some stars. They may look small, but many of those stars that you see are actually incredibly large. Many stars are larger than our own sun, which, as you may remember, is big enough to fit 1,000,000 Earths inside. The stars only look small because they are so far away. Everything looks smaller when it's far away. Think of how small an airplane looks when it's high up in the sky. And the stars look like they're blinking, but actually, they're shining steadily. The gases in our atmosphere cause their light to look like it's twinkling. So, the stars, they're not small. They're huge. They're huge. They just look small because they're far away. If you want to try a quick little experiment, you can put two objects. You can pick two things. So maybe I would pick my ball. My globe. So when it's close to my face, it looks pretty big, right? It's bigger than my face. I can see it though. But if I were to put this, so when it's right next to me, when it's close to the computer, it looks kind of big, right? But if I were to put this over near my sink, or to put it further away, you can hardly see it. It's pretty small, right? Oops. There you go. Looks so much smaller, doesn't it? But it didn't shrink. It's still the same size. It's just farther away. You guys can try that in your own home, too. All right. Then we also talked about how the lights, when you go outside at nighttime, sometimes they look like they're twinkling or like they're flashing, right? But they're not actually. It's just that the gases in our atmosphere make the stars look like they're flashing or twinkling. Okay? So, just how far away are the stars? Here's one way to think about it. If someone put you on the fastest rocket ship today and launched you out into outer space, it would take you thousands of years, about 73,000 to be exact, to reach the nearest star beyond our sun. That's pretty far away. However, you can still see the light from the massive hot star, even though it looks like a tiny twinkling diamond from here on Earth. So let's just think about that for a second. In the fastest rocket ship, it would take us 3 months to get to the sun, if we didn't burn up that first. But if we wanted to go to the next closest star, it would take 73,000 years. That is way longer than any of us will ever live. Okay? That would take a long time. So that must mean that it is really far, right? Okay. At night, astronomers study the stars. Astronomers work in observatories, which are buildings where large telescopes are housed. So we also talked about observatories with the Maya, remember? The Maya used observatories to look at the stars so that they could make our calendar, right? And they believed that those stars and those planets were gods. All right, so remember, telescopes are tube-like tools with lenses and mirrors used for magnifying or making objects bigger in space so that we can observe them or look at them. Observatories are built up on high hills or mountaintops where there are no buildings or trees blocking the telescope. What smaller word do you hear in the word observatories? Observatories. What word do you hear? Observe. And observe means to look. The roof of the observatory is designed so that it can open and allow the giant telescope inside to move up and down and all around without bumping into anything. Astronomers need really big, powerful telescopes to do their work. This is the kind of telescope you find inside an observatory. That's a big telescope. But you don't need a massive telescope and a fancy mountaintop observatory to enjoy the wonders of stargazing or looking at the stars. If you want a better look at the stars or a closer look at the moon, a pair of binoculars will do the trick. Hold your hands to your eyes. You got some binoculars. Okay. Or you could use a telescope like this one. You'd be surprised by all the different things you can see through a telescope. Okay, so these are pictures of stars that have been made larger or have been magnified. Through careful study, astronomers have figured out many interesting facts about stars. Even though no person is able to travel and study a star up close. So even though, as we learned, it would be possible to travel to our sun because it would only take a few months to get there, we wouldn't want to do that because the sun is far too hot, right? If we got to the sun, we would burn up. Astronomers have learned that some stars are older than other stars. Some stars are hotter than other stars. Some appear red through the telescope, and some appear blue. Stars change color depending on how hot they are, and how hot a star depends on its age, size, and other factors. So the reason they're different colors is because they're probably different ages, so they're different. One is not as old as the other. One might be hotter than the other, and one might be bigger than the other, and that's what controls what color they are. Kind of cool, right? But you don't need a telescope in order to appreciate the wonders of outer space. If you look at the sky long enough on any given night, you will eventually see a meteor or a shooting star. A meteor is the light we see when a rock that flies through space enters Earth's atmosphere. Now remember, the Earth's atmosphere is that bubble of air that surrounds our Earth, okay? So when something from outer space enters into our atmosphere, into the bubble, towards Earth, that is when we have a meteor. The meteor, or a bright light, appears as a streak in the sky before it disappears in the blink of an eye. At first glance, a meteor may look like a star is literally falling through the sky. However, stars do not move like that. Meteors, although they are sometimes called shooting stars, are not stars at all. So if you see a shooting star, what are you really seeing? A meteor. So the light of a rock burning up in Earth's atmosphere. There are billions of rocks and other debris in outer space. Some are quite large, but most are tiny, between the sizes of a grain of sand and a baseball. So most of it's not very big. When rocks break in space, all the broken pieces or debris just move around together because there isn't enough gravity for them to fall anywhere. These rocks and debris are whizzing all over the place in outer space. Occasionally, one crashes down toward Earth. Before it can hit Earth's surface, however, it crashes into Earth's atmosphere. For a space rock, hitting the Earth's atmosphere is like a person running into a brick wall, except the atmosphere doesn't stop it. The rock or debris hits the atmosphere at an incredible speed and keeps moving through. As it does so, it generates intense heat. The rock burns up as it enters the uppermost parts of Earth's atmosphere, creating a streak of light, a meteor, or a shooting star, as some people might call it. So, if meteors occur all the time, why do we only see them at night? Because it's too light during the day to see them, right? Okay. Occasionally, bits and pieces of rock survive their trip through the Earth's atmosphere and fall to Earth. This is rare, but it does happen from time to time, and it is possible to find pieces of them on the ground. When part of a rock or debris survives the trip through the atmosphere and lands on Earth, it is called a meteorite. So when the meteor ends up making it through without burning all the way up, when it gets on Earth, when it lands on Earth, if you find one from space, it's called a meteorite. Okay? The meteorite in this picture is probably not the most exciting rock you've ever seen. but it's pretty amazing to think that it came from outer space. Sometimes, by studying meteorites, scientists discover new types of rock that don't even exist on Earth. That's really cool. We're going to learn about rocks in the next domain, so in our next unit. Outer space is a strange and wonderful place. By studying the stars, planets, and other objects in space, astronomers have learned many things about this incredible universe, of which we and our planet are but a teeny tiny part. So remember, the universe is everything in space taken all together, including all the planets, all the stars, and all of space itself. Feast your eyes on this massive star cluster or group for a moment and imagine, if you can, the incredible number of stars and the incredible distances between us and them, and how much there is for us to learn about our universe. For instance, look at the very center of this photo. There in the middle is a little cluster of 14 bluish stars. Added together, astronomers estimate that these 14 stars combined are over 20,000 times larger than our sun. And remember, our sun is 1 million times bigger than our Earth. So that's huge. It's hard to think about. And it's just 14 stars out of all the stars in that picture. So think about how much space that has to take up. And that's only 14 stars in that whole picture. Crazy. All right, guys. I hope you enjoyed that story as much as I do. I love astronomy. I don't know if you've learned that yet, but I love it. So, when we look up at the stars at night, they look like they are blinking and they look tiny. Are stars actually tiny and blinking? No. Why do they look like they're blinking? Gases in our atmosphere cause stars to look like they're twinkling. And why do they look tiny? Because they're really far away. Remember, it said that it would take 73,000 years in the world's fastest rocket ship to get there. Okay. All right, what's next? Stargazers stand outside and look up at the stars, sometimes using binoculars. Astronomers have special buildings they go to in order to study the stars. Do you know what those buildings are called? Observatories. And what tools do astronomers use to see the stars more clearly? Telescopes. So we learned that not all stars are the same. Why are some stars blue and some stars red? Some are hotter than others because of their age, size, and other factors. So their color depends on how old they are, how big they are, and then some other stuff too. Okay. If you look up in the sky at night, you might see a streak of light, sometimes called a shooting star. Is it really a star? No. Do any stars fall through the sky? No. What are you probably seeing? A meteor, right? And what's a meteor? A rock or a piece of debris that falls through space. And what happens to the meteors when they hit Earth's atmosphere? They burn up, and they normally burn up completely. But what happens if they don't burn up completely and they end up on Earth? Then what are they called? Meteorites. Very good. Okie dokie. Word work time. So in the read aloud you heard, at dusk, just after the sun had set in the west, but before all of its light had faded, the first stars of the night appear. Say the word dusk with me. Dusk. Can you say it in a mouse voice? Dusk. Can you say it in a whisper voice? Dusk. Can you say it in a monster voice? Dusk. Can you say it in a robot voice? Dusk. All right, so remember, dusk is the time of day just after the sun has gone down, so just after sunset, when the sky is not yet as dark as it will be, right? When there's still a little bit of light from the sun poking up over the horizon. The sky glows with the colors of the sunset at dusk. Oh my goodness. Sorry, now I lost my train of thought. When the day ends and the night begins. All right, so we're going to do a little game. You are going to stand up if it happens during dusk, and you are going to sit down if it does not happen during dusk. Now remember, the opposite of dusk, so the opposite of the sunset, is the sunrise. And the opposite of dusk is dawn. So dawn is when the sun comes up, dusk is when the sun goes down. So the sun sets. That happens at dusk. What about the sun rises? That happens at dawn. The stars fade. So that means the stars, you can't see them. That happens at dawn. The stars appear brighter. That happens at dusk. What about the moon rises? That happens at dusk as well. Okay. So let's make sure we've hit all of our learning targets. We explained why the sun appears to be moving across the sky. It is because Earth is rotating and revolving around the sun. So when the Earth is when the part of the Earth that we are on is facing the sun is able to shine on it. So light, day. And when this part, where's my hand? This part can't get the sunshine from my face, right? If my face is the sunshine is hitting this part of the globe, but it's not getting to the backside. So the backside is dark. So the backside is nighttime. Okay. And then we were able to describe the appearance of stars. So talk about what stars look like. We demonstrated an understanding of the words dusk and dawn. And we are going to compare and contrast factual and fictional texts about stars in our journals. All right, guys. See you next time.